Hello, welcome to our second lesson in circle theorem for today. So in our first lesson, we looked at parts of the circle. We looked at parts of the circle where we talk about the center being the fixed point. We talked about the circumference being the length of boundary of the circle, and then the radius being the equal distance from the center to the circumference. We also talked about the chord. We said that the chord is a line within a circle that touches the circumference at 2 points. Then finally we looked at the diameter of a circle. We said that the diameter is a special type of chord because it's the only chord that passes through the center of the circle. Today we'll be looking at the theorems of the circle, that is the circle theorems. Now, circle theorem is basically some facts about the circle, so some proving properties of the circle, some proving properties of a circle, some proving properties of a circle. Now, this theorem that we are going to look at, you can prove it through construction, but we are not going to do that. So we are going to use algebra way. We are going to calculate it, okay? So letters will be substituted in place of angles, then we'll be asked to calculate for the value of those angles. But with construction, you can construct following steps to get these angles or values of what angles. So we want to look at the first theorem. It's not in any particular order, but we just want to take it as the first one. So let's look at first theorem. Good. So we'll be looking at the first theorem. So let's have our circle. Good. So now, the first theorem is about the diameter of a circle. So it's about the diameter of a circle. So we all know that if this is the center, then this line passing through the center is a diameter. Now the theorem states that if this diameter forms any angle at the circumference, if this diameter forms any angle at the circumference, that angle at the circumference is 90 degrees. So the measure of the angle that will be formed at the circumference of a circle by a diameter is 90 degrees. So so this diameter subtended this angle here at the circumference. So the theorem says that this angle is 90 degrees. So if a diameter forms any angle at the circumference, that angle will be exactly 90 degrees. So it can be from here also, this one, this one. So this angle formed here will be exactly 90 degrees. So that is the first theorem. The same can apply here. The diameter, this subtending this. So this angle too is what? A 90 degrees angle. So that is the first theorem. That is the first theorem. The first theorem. So you can state it down. That's what? Any angle, the diameter forms at the circumference of a circle is 90 degrees. So any angle the diameter forms at the circumference is 90 degrees. So you have to bear in mind that. You have to bear in mind this theorem. Good. So let's try our hands on a question applying this theorem. Good. So example 1. Find the value of x in the diagram below. Find the value of x in the diagram below. So let's look at our diagram. We are looking at our diagram. Good. So I'll do this one with you, the next one you will do it. Good. So this is our center. So we have this question: find the value of x in the diagram below. Find the value of x in the diagram below. So let's look at how to go about this. Good. So now, first of all, you can see that we are applying the theorem that we just learned. So now we have a circle, and then we can identify a diameter. So from the theorem that we just learned, we said that any angle that the diameter of a circle forms at the circumference, that angle is what? 90 degrees. So straight away we should know that this angle here is what? 90 degrees. It is 90 degrees because it is the angle formed by what? This diameter. And that is what the theorem says, that any angle that the diameter subtend at the circumference, that angle is what? 90 degrees. So first of all, we have to know that this is 90 degrees from the theorem. Then we have to look for x. Now you can observe that ABC is a triangle. So we have triangle ABC. Triangle ABC is a triangle. And we know from plane geometry 1 that the sum of interior angles of a triangle is what? 180 degrees. The sum of interior angles of a triangle is 180 degrees. So we'll apply that concept here. Now the theorem has made us aware that this angle is 90. So knowing that this is 90, the 90 plus this 30 plus the x should be equal to what? 180 degrees. I hope you get it. Good. So let's now solve for x. So we know that angle BAC plus angle ABC plus angle BCA should be equal to 180 degrees. Good. Should be equal to 180 degrees. So now, so angle BAC from the diagram, angle BAC is the x. So our x. So our x plus angle ABC is 90 degrees. Then angle BCA is 30 degrees. So this should be equal to 180 degrees. So now I want to look at our x. So our x plus 90 plus this one will give us what? 120 degrees. This will be equal to 180 degrees. So now, making x the subject, we are going to have 180 degrees minus 120. Sorry, 120 degrees. So our x will be equal to what? 60 degrees. Okay, so our x will be equal to 60 degrees. Good. So let's go over. So we have to find x. We have to find x. We have to find x. So we know that x plus this, the 30 degrees here, will give us 180 degrees. X plus 90 plus 30 will give us 180 degrees because the sum of interior angles of a triangle add up to what? 180 degrees. And the theorem helped us to know that this angle is what? 90 degrees. So combining the theorem with our previous knowledge of plane geometry, that the sum of interior angles of a triangle is 180 degrees, we solve for x. So now angle BAC plus angle ABC plus angle BCA is equal to 180 degrees. So substituting, we have x plus 90 degrees plus 30 degrees equal to 180 degrees. Then x plus 120 degrees plus 180 degrees. Sorry, x plus 120 degrees equals 180 degrees. So x equals 180 degrees minus 120 degrees. And when you simplify, you are going to get x is equal to what? 60 degrees. Good. So now let me give you your own to try. Let me give you your own to try. So this example 2 is for you. Solve it for me. So find okay. So try your hands on this one. I'm giving you, let's say, so 4 minutes. 4 minutes. Try your hands on this one. Okay, so let's see whether what you have down is the actual answer. So solution. Let's look at the solution. So as we said, we have to observe and see whether the property that we just learned is in the diagram. So in the diagram you have a center with a diameter. So the diameter is YZ, and this diameter has subtended an angle at the circumference, which from the theorem is supposed to be what? 90 degrees. So the theorem has enabled us to know that this angle at X is 90 degrees. So now the question said we should find angle XYZ. Angle XYZ. So this angle. And we know that XYZ is a triangle, so we have triangle XYZ, and from plane geometry 1, the sum of interior angles of a triangle is what? 180 degrees. So it means that angle XYZ plus angle YZX plus angle ZXY should be equal to 180 degrees. Okay, should be equal to 180 degrees. So angle XYZ from the diagram is what we are looking for, so we'll maintain it, plus angle YZX is the 90 degrees, and then angle ZXY, angle ZXY, so it's rather angle YZX is rather 70. So we'll correct that. Good. Good. So this is rather 70, and this is what? 90, and it should be equal to 180 degrees. So angle XYZ plus this one will give us 160 degrees will be equal to 180 degrees. So angle XYZ will be equal to 180 degrees minus 160 degrees, and this will give us 20 degrees. So angle XYZ is 20 degrees. So if you presented your answer this way, you are right. Good. So students, we'll end our lesson here for today. So the next time we meet, we'll look at the second theorem, then we'll also solve an example on the second theorem. Thank you. We'll meet again next time.